Hello and welcome back to our weekly seminar of Bullows Paint Shop Tales. In today's video, we are going to check out a different topic from our usual application-based video. And in this video, we are going to cover an automation project which we had supplied to one of our customers. This was a unique scope because we had made some slight modification for the requirement of the customer. And this one was that it included a multi-axis fixture system for the spray gun integrated with the PLC. And it also included a rotating base for the component. So it's an interesting topic. And so let's get and start with it. Now, as we all know, in today's world, where we have different types of coatings and industrial application, the number one thing that's important is the consistency. If there is no consistency, then the only thing which we are going to get is loss. Now, for manufacturers who are primarily into who make parts which are small casted components of any metal. The difference between a profitable run business and where in one scenario we have costly rejections, number of rejections as well as paint wastage, it comes down to the efficiency of the operator. If the operator is skilled, then you're bound to get good result. But if the operator is not skilled, then there may be inconsistency and losses mounting up. But the thing is that no matter the painter and no matter his experience, we cannot predict that it would be a perfect coating application for every component from the start of the shift to the end of the shift. We cannot guarantee that there will be a zero fatigue. We cannot guarantee that there will be no variation because at the end of the day, it is a manual operator, human-based system. But there is one scenario where you can overcome all of these challenges. And at Bullows, we specifically target and are trusted worldwide in the industry for making compact, durable, and efficient turnkey solutions, which are designed primarily with one target keeping in mind, and that is upgradation of the customer's existing manual process into a semi-manual, semi-automatic to fully automatic process. So like one of the systems is the same which we are going to cover in our today's video. And even though it may seem that it is a complex system, the basics what we achieve at Bullows is what makes the total difference at the end. So let's get to it. Now, the first image you see here is the image of the actual component. It is a casted part used in an industry wherein the customer had one specific requirement. In most of the cases, you might know that the painting and coating is done to the outside of part of the component. This can be done for various things like preservation, for protection of the component, for visual aesthetic. There might be some properties like anti-corrosion, etc. So this was also similar type of application, but the requirement was that, as you can see, the internal threaded part of the component, that is the only part which needed to be painted. And this was also not any other normal paint, but a specialized paint uh, made by the company who manufacture the product in combination and working together with a paint manufacturer. So this paint is extremely expensive and also takes a lot of time to make. That's why they needed to coat only the internal threaded part of the component. And as you can expect, they were facing in the current manual process multiple challenges for this. So what were the challenges? We'll just have a go to it one by one. The number one was regarding the paint saving. As I said, the paint is complex and like because it is a customized paint, it is also extremely expensive compared to the other alternatives. And that's why the number one issue that the company was facing was related to the paint wastage because of the manual operation. And this in turn was directly affecting their profitability because there was a significant amount of loss due of because of paint wastage per component. The second issue they were facing was related to quality and a huge number of rejected parts. Because they were using a manual operator, there is bound to be inconsistency. No two operators are same, no two hands are same, and no two coating techniques are same. Even though they are experienced, there is bound to be inconsistency, irregularity in the flow, as well as underspray or overspray or overcoating of the component. In all of this above scenario, one thing was clear that there were a lot of rejected parts at the end of the production cycle, which not only affected their workflow, but also paint wastage. So this was the second thing they were facing. This is also a similar component from how they had multiple components, but the one thing that was clear was they only needed to cover the internal part. So this is another part in the image. And the third thing that they were facing issue was with the DFT requirement. For those who don't know what DFT is, DFT stands for dry film thickness. It is the thickness of the paint film which is coated on the component and is measured in microns because it is a very thin film because we are using spray application. So the required film thickness which the company required was around 8 to 10 microns per component on the coating side. But this was difficult to maintain because in manual spray gun, the paint outflow as well as the overspray are irregular and in normal painting application where you are just doing normal spray painting on some normal industrial casted component, it's not that big of an issue. But in this scenario where you needed precision, you needed time saving, and where you also wanted to save the paint, uh, then the DFT achievement required is a big parameter which needed to be achieved. So the requirement was 8 to 10, but due to irregularities from the operator as well as the manual spray gun, they were achieving under as well as over micron DFT on variable components. So this was actually a way, even a bigger issue than the paint saving from the above point. DFT was the biggest thing obstacle for them. And last but not least was the surface coverage issue that they were facing. Because you're using an manual operator, the skill level of the operator is directly proportional to the good coverage and consistent coverage of the component. If he is irregular, if he is skipping or he is not that much dedicated to the job, then there's a huge chance that the surface coverage area is not completely covered. The internal part which they wanted to cover. There might be some part where it is not covered at all, or some part where even the outside part of the component where you don't want the paint is also covered. So these were the four major obstacles that the company was facing using their manual painting operation. So when they came to Bullows for asking of a solution, we, our dedicated sales and technical team, had thorough discussion with the customer and based on the inputs collected, which is a standard procedure at our end, we came up with a solution which was due to price constraint was a middle ground between a manual and a fully automatic system. So ours was a big middle ground which fitted in the budget, but also we were able to overcome all the four obstacles from above. Now, the Bullows system had five major components, which, when linked together, created the perfect auto coating system. We are going to check it one by one in detail, but to go through the list, the primary thing component in the system was our modular dry type spray painting booth, which is also environmentally pollution control board norms compliant. The second major thing, which was the applicator, in this case, it was the WA101 automatic spray gun Bullows make, which was decided after multiple testing of guns. We finalized on this particular gun because it tick marked all the parameters which we were hoping for. The third part is the multi-axis gun fixture, which was designed to keep multiple axis and movement freely available to the spray gun, because if the component changes, then the operator also has the ability to change the position of the gun. The fourth part is the rotary base system. This was a unique system which we integrated, uh, in which the base is actually the one on which the component is placed, which is rotated instead of moving the gun in all the other axes. This was one of the techniques which allowed us to create a cost-effective yet thoroughly durable system. And last but not least is the integrated PLC control, which is why the name fully automatic system comes into play, because the entire setup is controlled as well as programmable and modifiable through the PLC. So let's get it and understand each of the component in detail. The first one is our modular dry type spray painting booth. So the booth image is right in front of you. As you can see, because the component is small, it is the size is like a normal adult palm size. So as you can see, it can fit in the palm of your hands. That's why a bigger booth was not required. The requirement was that a single operator can be able to use this machine and place the component and be able to use it without any issue. The second thing was also space consideration. They were constrained in their factory location. That's why they needed a small size but effective coating booth. So that's why we designed this particularly compact type of a modular booth in the system. Now, as you can see, this is a dry type of a spray painting booth. Because due to using our automatic gun, the overspray was largely reduced, and even though the production was high, we managed to choose with the dry type booth because it comes with two types of filters. One is the dry type filter, which is fiberglass material, and the second one is the metal baffle filters, which are reusable and recleanable. When you combine both of these filters, there is little to no exhaust paint as well as fumes which are left into the environment. Everything 100% is captured in these filters and clean air is been sent out. That's why the booth is all PUC board norms compliant. So a single operator can stand in front of the booth, operate the booth, and it's easy as well as quick to use and adaptable as well. So the benefit was it creates a dust-free atmosphere for the component. So there's also less chance of contamination during the painting process. The modular design is also easy for installation, but it's also similarly easy and less time consuming when you comes during the maintenance part, that is changing the filters and other aspects without disruption. That's the best part. The next important thing is the choosing of the applicator. So we went ahead with, after multiple tests, we went ahead with the Bullows WA101 automatic spray gun. We chose this gun because of three things. One was it was built for precision. So this spray gun fits perfectly with the small paint saving application which was required. It also has a unique trigger mechanism which is fast and efficient. So there are no leakages, drippings, or sputtering when we spray the paint. The second is also material saving. There's a ratchet mechanism which provides extremely finer adjustment to the fluid flow as well as airflow and pattern flow of the to the gun. That's why it's easy to customize and choose finer parameters based on the application. And last is the consistency. The Bullows WA101 has been proven multiple times in various applications at various customer projects, wherein it has worked flawlessly without any issue. And since it comes with also rugged metal body as well as SS stainless steel needle, it is durable as well as the space requirement is also low. The third part of the system is the multi-axis gun fixture, which we also is in-house designed and manufactured during the booth process. The best thing is that it is a fully adjustable gun fixture. As you can see in the image, this is the front facing side of the booth. On the right hand side, we have the start stop switch, which is again integrated into the PLC. Pressing the button will start and stop the coating application. We have adjusted a ratchet type of mechanism into the mounting of the gun on the fixture, which allows the gun to move right, left, as well as up and down, as well as there is a swivel motion also given to the gun. So it can also move around its axis. The advantage of this system is that if the component changes, the component length changes, width changes, it can be totally customized and the gun position can be adjusted for every component, as well as we can also have a different program for different components pre-programmed into the PLC. So this thing provides adjustment range. It also provides swivel compatibility, but most importantly, it provides application flexibility to the customer. Since they said that currently they have two or three components, which we see in the photo above, but in the future they're also hoping to add different other types of components. Even though the sizes will be same, their shape might be different. So even for future foreseeable application, this system is totally compatible with that as well. And this also provides a perfect sweet spot between a manual system as well as a fully robot auto system. It's a good middle ground between those. The next thing is the important part, which was designed in the system, that is the precision rotary base. Now, what this actually is that the base of the component is rotated with the help of an electric motor, which is, as you can see, is at the bottom, mounted at the bottom of the booth. And as usual, this is also totally controlled by the PLC. So this is the base is rotated using a high torque electric motor. And since it is totally programmable, the speed of the rotating motion is pre-decided based on our initial testing for every component so that it rotates only the required amount of rotations, that is 360-degree once or twice based on the DFT required for the component, and just stops after that. So each cycle is predetermined. This also creates consistency and eliminates the need for using a robotic system, which might have increased the cost of the entire system. And since we wanted to go with the middle ground budget-oriented system without compromising on the coding ability, this system fits perfectly in that. Now, the fifth component and the last component is the PLC. This is the intelligent core of the system, and it stands for Programmable Logic Controller. Various cycle have been pre-programmed using logic into the PLC for various components. It sort of provides a digital handshake between the start and stop of the spray gun, as well as the rotating base. So they are conveniently moving in conjunction so that no two parts get irregular coating. And the last thing it also provides is precision timing. No matter how good the operator is, he won't be able to do good coating and in a set duration. For example, if the operator is supposed to do the entire coating of the component in, let's say, 4 or 5 seconds, but he won't be able to achieve the same consistency for each component every time. Sometimes he may do 3 seconds, sometimes he may do 5 seconds, sometimes he may go even overboard by 6 seconds. And that would lead to material wastage, overspray, and all other inconsistency. But when you're using the PLC, it you're guaranteed that even though you close your eyes, the component will be rotated the set amount of rotation. The spray gun will only turn on and spray only the predefined in amount of paint, that is in ml, to the component, and you are bound to achieve the same consistent coating in DFT as well as in visual appeal for the first component as well as the last component at the end of the shift. So let's just understand how the workflow or the process for the coating application goes. So the first step in the operation is the loading operation. So the operator who is standing in the front of the painting booth will place the component by hand onto the rotating base. The gun and all other mechanisms are already attached in the predefined position. So there is no need to change or have any motion change in that. The second stage is the initiation stage, wherein the operator presses the button at the right side, which we had seen above in the photo. So when he presses the red button at the right side, the cycle in the PLC starts. The third stage is the synchronization, wherein the PLC controls the movement of the rotating base as well as is also starts the spray option of the spray gun. As this is pre-programmed, this is works in conjunction and there is no ups and downs for it. The fourth stage is the spray window, wherein the auto gun triggers the exact amount of paint required for the exact set duration onto the component and the coating is done. And the last stage is the completion. The gun, as soon as the timer sets off, the gun spray control is cut off, as well as the rotating motion of the base is also stopped. So this also prevents double coating and also prevents wastage. Whereas in a manual coating, even though if we had a rotating base, but if it was a operator who was doing the painting, there's a high chance that he will do double or even triple coating, which is more than the paint required for each component. So for example, if the part takes 2 seconds to spin, the gun sprays for exactly 2 seconds, no more, no less. as well as the component only rotates 360-degree once. So there is only one clockwise rotation happening on the component. The other thing that this thing also eliminates is the overspray. Since because you have already adjusted the amount of paint flowing out of the system and the automation pressure, so there's minimal overspray, and thus the filters will also get clogged less at the end, and thus you have to also reduce the duration between which you have to replace the filters. So that is also an added benefit. Now, based on our test taken of the system at customer end, we have written down a table chart of all the details technically. We'll just go through it one by one to so all of you can understand of how much the paint saving is actually happening in the system. So the production quantity per shift was around 280 components. There was only a single shift at their end. And when they were using the manual operation, they were consuming about roughly 6 ml of paint. In some cases, even more, like I said, due to inconsistency per component. Now, when they switched to the Bullows auto painting system, the based on our trial ends and due to pre-programming, which our technical team had done, the paint consumption was directly reduced 50%. That is per component, it was now only 3 ml of paint was used. So we can automatically get based on rough estimates. So if they were consuming 6 ml before, so there is directly 3 ml of paint saved per component. Now, like I said, the paint was also extremely costly to them since they had specifically developed it. So the cost was around 10 rupees per ml of the paint. So when we do the calculation per component, they were now saving because of our Bolo system, 30 rupees per component. And the total paint saved per shift was around 840 ml. So the total cost per shift was around 8,400 per shift they were saving. So this was a directly saving from day one. Now, if you go by the month, considering 26 days, so it goes to around 21,840 ml of paint was saved. And if you go by the same cost for per month, it goes to around a whopping 2,18,400 rupees of paint save directly by switching to a system which eliminates inconsistency. So as you can see, this is a major plus point to the customer because when due to switching of the system from a manual operation to the Bullows automatic painting application. So the return on investment is also quite quick in that sense. And if they go on to do, let's say, 2 shifts, then the saving is directly doubled. Or they go on to increase the production even more since during the manual process they were doing 280, so they did the same test on auto process. But now as they are also consuming less time per component per shift, they can also do more than 280 components per shift. So that is also a win-win situation for the customer. So why this setup was a game changer, we'll just go through it in brief, one by one. The number one thing is the zero wastage philosophy. In manual painting, roughly around 30% of the paint is lost in overspray. This is due to operator negligence or the way in which manual guns work in general. And the paint is only released when there is a surface to receive it. When we log the system of the spray time as well as the rotation speed of the component, this ensures that only the required amount of paint is used. Next is the scalability of small parts. If you are a manufacturer who primarily makes small industrial components, no matter for which industry application, can be gears, can be pulleys, can be even brake disc, or even some motor housings. Then using or going with a very expensive system like a conveyor's line or some other aspects is going to be super expensive, as well as it's going to be overkill for the requirement. So for these particular scenarios, going with a system like our Bullows portable painting booth and this small modular automation techniques can benefit a big time to reduce the footprint as well as reduce the working area also. The third part is the reduced cost. Since auto systems are programmed, predefined based on our internal testing, there is saving on both sides. That is, there is saving on paint coating. There is also saving on material wastage, since there are now a lot less number of rejections in the at the end of the production cycle. There's also less parts of defective painting and coating, and this also saves the time of the production. So you can also increase the production while minimizing the defects and scrapped parts. There is also the added advantage of getting identical twins of coating application every time. So when you are using an operator, the approximately, if you go by the industry standard, around you will get 50% of the components or even more or less if the operator is skilled within the set parameters set by the paint shop. But 50% or more goes wherein there are inconsistency. Now it cannot be changed, it cannot be done any improvement in that because it's a human error, there is a human operator, and there is bound to be changes in that. So no two components are going to be same, which is done by a human. The first component, which is at the starting of the shift, might not even look the same compared to a component which was painted by the same operator at the end of the shift. Now, this is also because there's operator fatigue, there's also operator negligence and various other aspects. So you will never get two components which are similarly coated and wherein you won't be able to tell the difference that which component it was painted at which time. That is not bound to happen in manual operation. But with this system, you will get consistent painting coverage starting of the shift as well as at the end of the shift. And last but not least, the most important part of this system is the increased safety of workers. Now, as you know, painting is a hazardous coating application. That's why the operator has to operator has to wear all the PPE kit and everything, using the mask and goggles, everything, because some paints or some coating liquids are hazardous, they are harmful, and inhaling them can cause issue to the human operator. So in these cases, to also increase or reduce the operator harm, going with an automatic system is beneficial to the company, since they are not only saving time, they are saving paint, but they are also ensuring that the operator is safe and he is well outside the limit of the painting space. So the operator can just press a button, the coating is done, but while the coating is been done, he can go one or two steps behind a little far away. So that's why the hazardous air as well as exhaust fumes of the overspray are captured by the booth, and there is little to no chance of harm coming to the operator. So that is the one of the best win-win situation, which increases the safety of the workers. So this was the system. We also have a video of the system on our YouTube channel, which we are going to just see now. So you can also get a 360-degree perspective of how the coating is done. So we'll just see the video. So that was the video. Hope you had a good look around the entire system. So the last closing statement of our system. So the Bullows automated rotary printing system, it represents a good fundamental shift from spraying to coating engineering, wherein we are upgrading customers from manual coating process to a really good auto coating process, which saves them a lot of time. So with this system, the manufacturers can stop hoping for quality, but now actually start guaranteeing the quality of their production. So this system bridges the gap between a normal standard manual labor operator process and a full-scale robotic application. It's a good middle ground, and our system offers a turnkey solution that delivers on five major points. One is the consistency, so that the coating is predefined to the exact specification. Second is the efficiency to reduce wastage. Third is the quality. So no, all the components are similarly coated with the same DFT. Fourth is the safety of the operator from exposure to harmful chemicals and fumes, overspray. And last is the scalability. So as the system is modular as well as it's takes such a small space, the manufacturer can increase the scale of the production by increasing this system linearly based on their production. So that's it for today's video. Hope you had a good time and learned a lot about the system. Just like this system, if you have a coating application wherein you're thinking about switching from your old traditional ways of manual operation to a good future ready system of automation, you can just give us a call anytime and our team will be available to help you for it. If you want to check other systems and other coding applications which we have done in the past, you can check our Bullows YouTube channel as well as our website to have a look around it. We have multiple coding applications and various systems production videos there which you can have a look around. So if you whenever want to get in contact, you can contact us through social media sites, through our mail, website, and mobile number, and we'll be there to help you. All the details of these things are in the video description. You can just have a look around it. And just like that, we'll see you again in a similar video next week, putting yet another application or one of our case studies just like this one. And we'll see you again in the next time. Thank you.